Hello all, welcome to Public Cloud Design Tips and Tricks for another new topic. The topic is Azure Container Apps. The problem statement is how to manage container applications and microservices in a serverless platform. Now, what is Azure Container Apps? It is a managed service from Azure that enables developers to build microservices or container application with a serverless architecture. It is powered by Kubernetes underneath, and it is enabled by open source technologies like Dapper. Dapper stands for Distributed Application Runtime, APIs for microservices. KEDA is a Kubernetes event-driven autoscaler, and Envoy is a service proxy designed for cloud-native services. It also supports service discovery and traffic splitting, and autoscale based on traffic and events like messages and queues that we'll discuss later. It can also support background processes and long-running processes. Okay. For knowledge, I have taken one reference architecture from Microsoft, which is Dapper integrated with microservices, and then microservice is also attached to a messaging service. Okay, here it's a topic. Okay, so that is on a very high level. It looks like. Now there are different type of scenarios possible within Azure Container Apps, and they are like first is public endpoints where it's more a web-based services or microservices you can say, which is exposed to HTTP and HTTPS traffic, and that traffic again reroutes by some proxy to revision 1 and revision 2. Those are nothing but the snapshots of container images basically that we'll discuss later. So that is public endpoints. Background processing is a continuous process running in the background, which can be a program that does data transformation. Event driven is a process that is more gets triggers based on the event. For example, a message in a service bus queue, that is event driven, and microservices are more deployment of multiple microservices with an option to integrate with Dapper capability. Okay, so these are the different scenario which is possible in container apps. Now there are different auto scale criteria possible in container apps as well, based on the scenarios we already discussed now. So public endpoints are more request based, HTTP request based. So scaling is always based on number of concurrent requests, okay, coming to the application. Background processing is more volume based, so it's directly depends on CPU and memory of the systems which is it's running on. So that is where the scaling happens based on CPU and memory statistics. Event driven is always based on the number of events that is or the message that is in a queue. And microservices are again, each microservices can be scaled using the KEDA capability. Okay, so which scale the trigger, which actually triggers the scaling. Okay, so that is how it is actually. And now container Azure Container Apps manages the details of Kubernetes and container orchestration for any specific projects. So it supports Linux based x86 64 systems basically, and containers are nothing but again images basically, the runtime form of any images, and it can be from public or private registry. Okay, now it should have a qualified domain name, and it supports HTTPS port basically. Okay. Uh, Now configuration can be done. Container configuration can be done using a configuration file called properties.template in the section of containers actually. So there is a section containers, and within that you can define your container statistics. Okay. I have also taken a reference link from Microsoft where you can go and see how you can define a containers. Okay, within the template file. Now, this is the most fundamental and important thing of a container app is revision. So, what is a revision? A revision is an immutable snapshot of container app version. Okay. So, whenever you deploy a container application, the first version is called as first revision. Okay, by default at the runtime. Now, when you alter the revision using the revision scope, basically, which is very specific to a container application, then your second version gets created and so on. Okay, now revision changes get effected globally. Let's say you want to change something across the revisions, the number of revisions, then it's called global change, and that comes within application scope properties. Okay, at any point of time, there are 100 revisions you can retain in a container app platform. Okay, now multiple version of revision can be run at a time also. Okay, and you can also split the traffic, consumer traffic across the revisions based on your requirement. Okay, for example, let's say if you want to have a blue green kind of a deployment scenario, then you can very well split the traffic between the blue and green revisions. Okay, for example. Now, this is how the lifecycle management of a container app looks like, and it consists of three stages: deployment, update, and deactivation. So, deployment, we already discussed. The first initial version of a application automatically gets deployed with the first version or the default version revision 1, you can say. Okay, so that's a deployment. And on top of that, whatever changes you are doing and getting again deployed, it's called update. Okay, so with the revision scope change, a new revision gets created, and that is the update after the deployment. Okay, so at any point of time, you can have multiple updates with multiple revision. Okay, and say for example, at one point of time, you don't need one revision which is no longer in use, then you can very well deactivate it. Okay, so when a revision is no longer needed, you can deactivate it, and at any point of time, you can also reactivate it if you need so. Okay, so that is how it works. Now, from a security perspective, there are certain scenario where the consumer wants to have their container application within their own private network. Okay, so that is where network comes into picture. So, if you think container app in accessibility perspective, there are two kind of flavors possible: external and internal. Okay, so external are deployed with a virtual IP on an external public facing IP address. Okay, and on the other way, internal is always having an endpoint of a private address. Okay, so that private address IP can be of a load balancer, internal load balancer, that is issued from a virtual network of the private IP addresses. Okay, or from the subnets where it is hosted. Okay, so that is how it gets differentiated from external to internal. Okay, now Azure Container Apps, you just envoy as an HTTP proxy to route HTTP request to the downstream container apps. Okay, so proxy plays a role as a router from the consumer to the downstream revisions basically, and it supports HTTP1 and HTTP2 both. Okay, so that is how it works. So in private scenarios, you can have your own virtual network and subnets to deploy container apps to make it more secure. Okay, now this is a very high level overview of how Azure Container Apps looks like. If you want to know more about it, you can very well follow the links from Microsoft, and let's go deep dive into it and do some hands-on as well. That's it for the day. Thank you and have a good day.